Okay, right. Oh, yeah, we are here to talk about operations with polynomials. Um, and operations means addition, subtraction, multiplication, and division. So what's a polynomial? Excuse me. Poly means many, like polygon has many sides. Polyunsaturated fats has a lot of unsaturated fats. Nomial, like nomenclature or nominal, means terms or names. All right, so here's a polynomial. It's generally got a lot of terms in it, and they all have the form something times x to the power n. Now, n has to be a positive integer. All these powers are positive integers. And the biggest one, n, that's called the order or the degree. And this coefficient at the front is called leading coefficient. We'll talk more about this in a minute. So each of these terms is called a monomial. So something times x to the something is called a monomial. Let's talk about operations with monomials. So to addition and subtraction, nice and easy. 2x squared plus 3x squared is 5x squared. But 2x squared plus 3x cubed, you can't do it because they're not like terms. Here we've got like terms, x to the power 4, x to the power 4. So 8x to the 4 minus 11x to the 4 is negative 3x to the 4. Multiplication, a little bit more exciting. You've got 2x squared times 3x squared. Now 2 times 3 is 6. X squared times x squared is x to the power 4. Now it gets a bit confusing when you've got x's and multiply signs, so I like to use my parentheses, my brackets a lot. So 6x to the 4 times 3x to the 5, well 6 times 3 is 18, x to the 4 times x to the 5 is x to the 9. Remember, you add the exponents. Oops, this is the wrong order, but anyway, 3x squared to the power 3, so it's like we're multiplying this by itself 3 times, is 3 to the power 3, 27, and x squared to the power 3 is x to the 6. Power of a power, say multiply. Division, well, 2x squared divided by 3x squared, the x squareds cancel out. We're assuming in this case that x does not equal 0. I should have written that. X does not equal 0. Same thing here. 10 divided by 2 is 5. X to the 5 divided by x to the 3 is x squared. Okay, so with these examples here, you need to remember your exponent laws. If you don't remember these, maybe take another good look over them. There's a couple of review exercises I've provided for you. Right, that was monomials. Let's talk about polynomials. So the thing here that I want you to focus on is the highest power. Highest power is called the degree. That's the American English. British English calls it order. And the coefficient, so a is a coefficient, x is a variable, n is the exponent or the power. So a is a coefficient, so the coefficient of the term with the highest power is called the leading coefficient. It's the one at the front when you do them in order. And we generally do them in order from the highest power to the lowest power. So let's have a look at this. Here's a polynomial. What's its degree? Well, it's 4, and the leading coefficient is 3. This one, degree is 8, leading coefficient is negative 4. This one, degree is 5. That's the highest power. I wrote it in non-standard form. So highest power, and this is the leading coefficient, right? This one here is not a polynomial, right? This is not a positive integer. This is not a positive integer. 11 over x is 11x to the power of negative 1, which is not a positive integer. These terms are not monomials, so they can't be a polynomial. Okay, by the way, this thing here is a polynomial expression. If I put an equals sign, equals 0, now it's a polynomial equation. We're going to deal with most of the expressions in the first little while and equations when we start graphing. Let's talk about polynomials then. So addition and subtraction, nice and simple. What you do is you group like terms. Alright, so the 2x squared here and the 3x squared here, group them together. Same the 4x and the minus 2x and the minus 5 and the plus 1, and you simplify it. Same over here. Group the like terms, but be very careful with your negative signs. And remember that minus negative means plus. Okay, with multiplication, I've got 4 examples here, and it's all just a matter of expanding them out using the distributive law. So here it'll be 4 times each of these terms. In this example, we use the FOIL, which is a sort of a shorthand way of saying distributive law. So it's 4x times 2x, 4x times 1, negative 5 times 2x, negative 5 times 1. And then you've got 2 terms that are x, so you simplify them. This example, we can't use FOIL anymore because we've got a few on the inside, so it's like FOIL. Alright, so it's 4x times 3x squared and 4x times 2x and 4x times 1 minus 5 times 3x squared and minus 5 times this minus 5 times that. Yep. And same here, you're multiplying each term on the left by each term on the right. So you have to, it becomes 9 terms there, but you simplify it down to 5 terms. Okay, because you've grouped together the cubes and the squares and the x's by themselves. Okay, division. Well, if you're just dividing by a simple monomial or just a simple constant, just divide each term by that number. Same thing here, divide each term. Remember, x cubed divided by x is x squared divided by x is x divided by x is 1. When you get to this, it becomes a lot harder. And there's 3 different methods that we're going to learn how to do this. Look at the next video. Here's a summary of how it's done. Okay, so 3 different ways. Alright, so now try 5.1.